Okay, section 2.6 is talking about proving angles congruent. And there's really just specific types that they're referring to. So the first theorem is vertical angles theorem. And that's important because we're going to talk about vertical angles that are congruent. So remember we said vertical angles are the ones that make the X shape, and you're using either the top and the bottom or the left and the right. So first thing is, it wants me to find the value of X in this visual. Well, we just got done discussing. I know vertical angles are congruent, and these two are on our opposite sides, so that means that these two are congruent. So if they're congruent, I'm going to go ahead and set those equal to each other to solve for what X is. So I put 2X plus 21 equaling 4X. So that means I'm going to subtract 2X over, and then I'm going to divide by 2, so I got X equaling 10 and a half. Go ahead and pause the video and try the next one. So on the next one we have another set of vertical angles. So I went ahead and set them equal to each other. So 3x equaling 2x plus 40. Then I'm going to subtract 2x over. So I get 1x equals 40 and divide by 1, so x is 40. Okay, so first thing is we talked about vertical angles are always congruent. Very, very, very important. The next part is, well, what's that look like if I'm asking you to prove something? Well, look at this one. They want me to prove that 2 is congruent to 3, given that 1 is congruent to 4. So what I like to do is I will go ahead and I mark it. So they told me 1 is congruent to 4. So I'm going to go ahead and put my marks in there. And in my proof statement, I'm going to go ahead and write that on my very first one. Now, going forward after that, since they don't give me anything else, I'm going to be asking myself, what do I know from this picture that I could use, but they haven't told me yet? Well, we just got done talking about vertical angles. So we just got done discussing that vertical angles are congruent. So, what if we take a pair of vertical angles and say that they're going to be congruent to each other? So I said that, well, 4 has to be congruent to 2 because they are opposite sides from each other for vertical angles. Now you could also say same thing for 1 and 3 if you wanted to. So I did the same thing on the next step. I also said 1 and 3 have to be congruent to each other because they are also a pair of vertical angles. Now notice that I have a couple things in common. Notice that in these two statements that these 4's are in common. Well, that's that transitive property / law of syllogism where these two things are in common, so I'm going to go ahead and say that 1 and 2 have to be congruent, and you could either look at it in terms of substitution if you wanted to, or it could be in terms of transitive property. Then I'm also going to say that since notice that the first and third statement have 1 in common, or sorry, the third and the fourth statement have 1 in common, then that means that 3 and 2 also have to be congruent to each other. And again, that's either by substitution or you can put it as transitive property either way. So that's giving you a look at where it's going, that you're trying to prove something by using your theorems or your postulates. And so you have to go off what you already know plus what they give you. Alright, let's take a look at some more theorems here. So the next theorem we have is the congruent supplements theorem. And that says if angle 1 and angle 3 are supplements, and what that means is that they would add to 180, and angle 2 and angle 3 are supplements, which means that they add to 180, then that means I know that 1 and 2 have to be congruent to each other. So these two angles congruent. Okay? Congruent complements theorem. If angle 1 and angle 2 are complements, which means they're complementary, add to 90. If 3 and 2 are complements, which means they add to 90, then I know that 1 and 3 have to be congruent. Theorem 2.4. All right angles are congruent. So if they're right angles, I know they're congruent. That's a no-brainer. Obviously, they're both 90, so you know they're going to be congruent. Don't know that we necessarily need a theorem for that, but if two angles are congruent, so such as 1 and 2, and 1 and 2 are supplementary, therefore they both have to be equal to 90. Again, not necessarily something that we probably need a theorem for because we could figure it out, but we do have something that says it. So now what I want you to do is pause the video, and I want you to try and set up a proof for the last example. So it says that we're given 1 and 2 are complementary and 2 and 3 are complementary. So we're going to prove that 1 and 3 are congruent. So I want you to pause the video and see if you can set up that proof. So remember, your first step is always writing down what you know. So I'm given 1 and 2 are complementary and given 2 and 3 are complementary. So you should have the first step. Remember, I'm trying to show that 1 and 3 are congruent. Well, if you look back up here in your theorems, that's exactly what this theorem is saying. If I have two sets that are congruent to the same angle, then I know those two angles have to be congruent. So this should be a two-step proof. 1 and 3 are congruent by that theorem, congruent complements theorem. Okay, we are still not there yet in terms of proofs, so we're going to keep practicing. Continue to work on it. I do know that they are challenging, so don't get so frustrated where you feel like you're never going to get it. It takes time, so you want to keep working and working, and then eventually it'll just be like a light bulb went off and you're like, oh yeah, how come I didn't get this before? So just continue to keep working and don't get frustrated because we will work together on it.